In this section, I'm going to look at how to create a scatter graph from a table of values or from two data sets and use it to form something called a line of best fit. Now, the reason we want to draw scatter graphs is we want to be able to try and observe or show relationships between two sets of data. So hopefully when I draw this out, I should hopefully be able to see a relationship here between the temperature outside and the number of ice creams that get sold each day. So let's look at this first example then. Over 7 days, a shop records the maximum outside temperature and the number of ice creams they sell. The results are shown in this table below. So all we've got here is each day the person in the shop takes a record of the temperature. On the first day it was 23 degrees and they sold 42 ice creams. The next day it was 16 degrees and they sold 18 ice creams, and so on, going through the 1, 2, 3, 4, 5, 6, 7 days. And we're being asked here to show this information on a scatter graph. Now to do that, what I need to do is just move this up a bit so we've got a bit of space to work with and start to draw out some axes. So before I start to draw them, I need to work out roughly how long I'm going to make them. So I'm going to look at the data here. For temperatures, my lowest value is 16 and my highest is 23 degrees. And for the number of ice creams sold, I think my lowest number of ice creams here is 18 and my highest is 42. I think I'm going to do ice creams going up the way and temperatures going across the way, which means I need a scale for ice creams going from 18 up to 42, so going this way. So I'm going to start to draw out a line here, which I'm going to mark off in 2s, so 2, 4, 6, 8, 10, 12, 14, 16, and hopefully I should have enough there to get all of my values on. So as we said here, we've got a number of ice creams going from the lowest of 18 up to 42, so if I start here and make this one down here at the bottom 18, I'm thinking I've probably got enough here, but I can always make it a bit longer. 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42 and 44. So that is enough to cover the lowest up to the highest value on this axis. So next to that, I'm going to write number of ice creams sold. For labelling the axis. And I need now another axis, which I'm going to put along the bottom here, which doesn't need to be quite as long because it's really going to be for the temperature, which we know only goes from 16 to 23. So again, I can mark that off now. So we'll just do that quickly, and we'll label that along the bottom as temperature. And the unit of temperature here is degrees Celsius. So I might put a T on the axis for temperature, and I'll put a N for number of ice creams on the y-axis. So what we've got here then is we need to start taking this data one bit at a time. So on a day when the temperature was 23, we sold 42 ice creams. So find 23 in my temperature range down here and go upwards until you reach the 42 degrees Celsius for that day. And right here, upwards from 23 and along from 42, we're going to mark off that piece of data right here. We're then going to move on to the next day, which was 16 degrees Celsius with a temperature of 18. So I'm going to find 16 on my temperature scale down here, and that's going to match up with the 18 on the number of ice creams sold. So I'm going to have to put a piece of data, a cross representing a piece of data right here, and we'll just continue on that vein. So third day, 18 degrees, goes with 24, so 18 degrees Celsius, moving upwards till I'm level with the 24 ice creams sold, so right here. And you would just continue this process going through each day at a time. Now, if we do that, your final scatter graph should look like this. And from that, hopefully we can see there is sort of a pattern emerging. The dots or the crosses here are going upwards as we go from left to right. So we can see there is a connection. As the temperature is increasing, the number of ice creams sold is increasing with it, giving us this upward kind of line here. Now, that's a positive correlation, a positive connection. As one value goes up, the other one goes up with it. What I would like to do now is go on to part B and draw a line of best fit. Now, a line of best fit is a line that we're going to draw on here. It has a few rules, which I'll put down here. And those rules are, it should have roughly the same number of crosses either side of it. And by that I mean these crosses here, and it should follow the rough direction of these crosses. But what I mean by that is you can see these crosses are sort of heading upwards off in that kind of direction. Now, the line of best fit is a straight line trying to meet these two criteria. So to give you an example of a bad line of best fit, first, just so you know what not to do, and it maybe makes it a bit easier to understand what to do. We'll draw in a line of best fit here. Now, what you can see here is the line of best fit I've drawn in. That's a terrible line of best fit. It meets one of the criteria. It's a straight line with roughly the same number of crosses either side of it. So 3 at that side, 4 at that side, that's roughly the same. But it doesn't meet criteria 2. It doesn't follow the direction of the crosses. Really, I want the line to be going upwards in this direction here. This line is going off in this direction here. So let's get rid of that line and draw in another line of best fit, or another attempt at a bad line of best fit. So here in this line of best fit, again, not a good line of best fit at all. Criteria 2 here, it meets, it's a straight line where it follows the direction of the crosses. In other words, these crosses are going up in this kind of direction. This line does roughly the same thing. It's going upwards from left to right. It's about the same steepness as where I expect my line of best fit to be from these crosses. But it doesn't meet this criteria here. It doesn't have roughly the same number of crosses either side of it. All of the crosses are at one side, and therefore this is a poor line of best fit, so we'll get rid of that. And lastly, what we'll do is we'll put in what would be a good line of best fit. So this is really what we're looking for. Following these two criteria up the side, roughly the same number of crosses either side, and follows the direction of the crosses. Now, if we look at this, this point are kind of lying on the line, so that's fine. This point and this point are maybe to the left of it, and this point maybe to the right of it. So roughly the same number either side, and it follows the direction of the crosses. The general pattern these crosses make would go in this upwards direction from left to right, and this line follows that pretty well. So this would be a good example of a line of best fit. In the next part, we'll look at going on to find the equation of a line of best fit, which is the equation of a straight line, something you should hopefully already be familiar with.